Advanced Testing and Performance. In this section, we're going to talk about performance and automated testing techniques on Android. So we'll start off with big O notation and data structures. Then we're going to move on to introduction to testing and Mockito framework. From there, we're going to take a look at the user interface testing with Espresso and integration tests. Finally, we'll cover UI, automator, and hallway testing. So let's start with big O notation. So big O notation, what does it mean? And in the end, it's basically just a measure of complexity of the algorithm. So let's take a look at these simple functions. All of them can show the complexity of the algorithm. So for example, log_n function, we know that it grows much slower than, for example, n squared function. And based on this, using big O notation for algorithms, we can say that, well, this algorithm is going to be much faster, it's going to execute much faster than the one, for example, that has n cubed time than the one that has log_n time. And from this graph, you can see right away how this complexity differs, by what magnitude. So log_n time complexity algorithm barely increases on the input. For example, O(n) time has a linear growth, which is just, well, regular growth and not really a special case. Most algorithms do that. And there are other more extreme cases like n squared time and cubed, which will show that this algorithm is really complex and can take really a lot of time to execute if the input is high. So this complexity can take place on the CPU, meaning that it will need to do more calculations, comparisons, or whatever using your CPU. It could take place in memory, meaning that your algorithm might require more memory or less memory, depending on its context. So let's take a look at this simple case where we are processing just one list and doing something with each of the items. So this is going to be O(n) time. And in this case, we can see that there is another loop inside the loop. So this could imply that the complexity is O(n) squared, or maybe O(n) times m if they're separate length lists. So, but what this implies that, well, this algorithm can take really long time if the input is really big. Obviously, all of this really depends on the context. If your function is really simple and fast, for example, log_n time or O(n) time, it doesn't really matter if it's going to be executed by some other call that has a complexity of O(n) squared, meaning that the very end performance of your entire call through is going to be like n cubed. So context always matters in where your algorithms are executed. So when you know all of this, it doesn't mean you have to necessarily provide and do early optimizations in your code. Before doing any optimizations, you need to always profile code, find your bottlenecks, what's the slowest part of your algo, and optimize that bit, and then move on to the next. In the next video, we're going to take a look at data structures that help us cope with big O complexity.